Hey guys, how you going? Hope you've had a great day. And we've got some people in the chat here. Hey guys, how you going? Hey, if you want to ask questions, we've got a Discord channel just in the bottom right here, of the bottom left of the screen here, and there's a link down below in the description of this video, of this live stream, and you can click on that and join the the Discord chat, and you can ask questions as I go along. We also have links down to our social media pages if you want to keep up to date. We can keep you up to date with the latest news in astronomy. We've got, it's been a big day. Well, it ended up being an anticlimax with SpaceX having to cancel their launch for today at 10 minutes before launch because of the weather, but they're going to reset for Saturday about 3:22, I think it is, for here in Perth in the morning. So another ungodly hour for us to get up and watch the live stream from SpaceX. So it's Sunday our time, not Saturday. So Sunday at 3:22. So we've also got our Patreon account there that allows us to continue doing this kind of stuff, and also maintain the observatory as well, because it's run by a volunteer group since 2015. So we're going to talk about the night sky here, because we've got a pretty fantastic night sky. If you joined our live stream on Saturday, we were out in the central wheat belt at one of our volunteers' private observatory, and we were able to, even though the clouds came in at the last minute, we were able to get a nice wide field view of the Milky Way with the emu in the sky, which we'll talk about in this chat here. And it was pretty spectacular because there was a light cloud across, which made this the stars a little diffuse and have a little coma around it, each star, which was pretty amazing. All right, so this is my what's in our night sky. So learn what activities you can do here in West Australia, what's up in the sky throughout the year, and also what astronomy tools you can get as well. So this is an image that we took with the Nikon camera on our first journey after it was donated. So Roger, who was on the live stream last Saturday, he and I went out to Southern Cross to do a astronomy night plus an astrophotography workshop there, and we were staying in Nulla retreat in Maureen Rock, I think it is, Maureen Rock or Creek, and fantastic place. They look after injured native species as well there, and no light pollution whatsoever. So this was a shot of the small Magellantic cloud and also the large Magellantic cloud. We've got the emu here, so this is the Coalsack Nebula, which is the head of the emu, and then the body here. The Southern Cross is around here, and we've got a little bit of the Carina Nebula right here as well. So you can just see this was a 20-second exposure at about 6400 ISO. So when you get to see what's out there when there's absolutely no light pollution, it's amazing what you can see. So, what activities can you do? Well, we've got our own night sky tours, and we also do off-site. These are put on by not only the observatories here, as the Perth Observatory or the Gravity Discovery Observatory in Gingin, but also these can be put on by councils and also by the schools and community groups as well. So usually they're who we interact with when we do our off-site events. And at these events you can be using telescopes, you can be using binoculars. They can show you, depending throughout the year, the moon, Jupiter, Saturn, nebulas, star clusters, and viewing sessions. They can go anywhere between an hour to an hour and two as well. You can also do astrophotography workshops, and they're pretty. They're really good to do. And the good thing about the technology nowadays is you can have a decent size, you can have just an ordinary camera, and at least you can still do stuff. And you can learn, you can improve your skills by, getting a copy of, say, Photoshop or Lightroom from Adobe, and you can actually edit the photos and touch them up as well. So there's a number of people that do it. Roger Groom, who was on the live stream again, hi Roger, from Astrophotography Australia, he does workshops and individual workshops as well, and he's even getting pretty nifty with doing them over Teams as well, Microsoft Teams, and also Zoom. Carol Redford from Stargazers WA also does them, and I do know that Camera House Midland, I think, and Camera Electric here in West Australia also do workshops as well. We have meteor showers which you can go and see throughout the year. Generally there's about 10 officially recognised ones which you can see in both hemispheres. Some you can only see in the northern hemisphere, some you can only see in the southern hemisphere. A classic example of this is that there is the Perseids, which is the main meteor shower. I think they're in August for the northern hemisphere. And you can get, if you're in a dark sky area, you can get 120 per hour. But we can't see them down here in Perth because we're just too low in the southern hemisphere. If you're in the top end of Australia, you might be able to see one or two. But with the southern hemisphere, we have the Geminids, which are in mid-December, and they're the ones to really see. And this is a photo from Roger Grew of the Geminids, and these are shots that are taken over for a while, and then he's composited them together so that you get a decent amount of meteors in one image. They usually last over a month, and then in the middle there's a peak night. So usually for the Geminids, it's around the 13th, 14th, 15th, which is the peak night. So, and we'll do events now at the Observatory for the Geminids, and they usually we get people in at say 10 and they leave at 2 a.m. because it's one of the more, they all happen at really horrible times for people that work during the day, but they do. At least with the Geminids, they do start relatively early for meteor showers at around about 10:30, and they go through till the rest of the night. So what's happening with these meteor showers is it's a little bit like driving down the freeway and coming up to a rain shower. You have the meteor showers are ice and dust particles that have come off the comet's tail, and when it's come into the inner solar system. And that material just stays in that orbit, and Earth eventually runs through that tail, and we get the night sky. So then we're not talking about pebble size or anything, or massive big pieces of rock. We're talking very, very small pieces, fine dust and ice, which we get to see in their lives in a fiery glory. And so going back to that metaphor of you're driving down the freeway and you hit a rain shower. The very beginning of the rain shower, you're just going to get a few spits on the windscreen, but as you're in the middle, it's pouring down with rain, and then when you leave, it starts getting you're just starting to get spits and just sprinkles of rain. There's also total solar eclipse. Now, this is something that is definitely on my bucket list. I have seen a partial solar eclipse back I think 2013 it was when we had a partial eclipse here over Perth. But this is something definitely to go see, and it's where the moon. We live in a very lucky time where the moon, even though the sun is 400 times further away. 400 times bigger than the moon is 400 times closer to us, and so at right times we can actually get a total solar eclipse where the moon blocks out some of that light, and this doesn't always happen because the moon's orbit isn't perfectly aligned to the equator. It's on a 5% incline, so sometimes it's a little bit higher, sometimes it's a little bit lower in the sky than the sun for a total solar eclipse during new moon. So it just has to be right. If you've got a program like Stellarium, which is a planetarium software, you can actually go through the year, have the moon tracking the moon, and just go through the days, and you'll see the moon traveling through above the sun sometimes it will be below, and it's exactly the same opposite for a total lunar eclipse, where it's, instead of the moon blocking the light from the sun, it's actually the Earth, and we'll get into that a little bit more. So another type of solar eclipse is an annular eclipse. Now, annular comes from the Latin word annulus, which means ring, and it's a total eclipse, but it's when the moon's orbit isn't perfectly circular. So it's egg-shaped. So sometimes it's a little bit closer, sometimes it's a little bit further away. So an annular eclipse is when it's roughly around where its furthest point is, and it means it doesn't completely cover the sun, and you also don't get that nice viewing of the corona or the atmosphere of the sun, because the moon blocks out the whole sun. And a French astronomer has this lovely term of what the difference between an annual eclipse and a total eclipse is like. Having a peck on the cheek is what an annular eclipse is, and French kissing is what a total solar eclipse is in terms of kissing. So that's another interesting way to put it. There's also a type of eclipse called a hybrid eclipse, where it goes from an annular eclipse to a hybrid eclipse, to a total solar eclipse. It's very, very rare. It doesn't happen. It happens very rarely over land. And there's actually going to be one in Exmouth on the 20th of April in 2023. So one side of Exmouth will actually see an annual eclipse, and as it gets to the other side, it'll become a total solar eclipse, which is going to be pretty amazing. If you're looking for hotels, apparently it's completely booked up in Exmouth, and they're expecting well over 20,000 people. So I've spoken to people who've worked in Exmouth, and they're just very interested to see how this is all going to work, because I think Exmouth has only about 2,000 people or so in it anyway. There's a partial solar eclipse, and this is where the moon only covers a small, doesn't completely cover the sun, just like we can see here in this photo. And so we can see that there's only a small bit of the moon on Earth that will actually get the total solar eclipse. On the other side here, so this is the umbra, this is the inner shadow of the moon, and then we've got the preumbra, which is the outer shadow. And so the people in the outer shadow of the preumbra, they'll experience a partial lunar eclipse, partial solar eclipse, and the people in the umbra here in this smaller circle will experience the total total solar eclipse as well. We also have lunar eclipses. Now, this is an image that I think Roger might have taken it, or it might have been Andrew. One of our volunteers, who's a fantastic astrophotographer, have taken this photo. It might even be me, but this is where the moon passes. Is a full moon, and it passes through the Earth's shadow. So we've got, just like we have here, we replace the Earth with the moon, and this is where you get the redness from. So the light is going through the atmosphere, through the Earth's atmosphere, and the reason our atmosphere is blue is because the nitrogen particles and oxygen particles absorb the blue light. So light is made up of three colors: red, yellow, and blue. If you that light that goes through the Earth's atmosphere has the blue light absorbed, and what's left over hits the moon. So what colors do you get when you mix red and yellow? You get orange. So that's where you get this blood red moon. So there's only two reasons you should see a red moon. Either it's a total lunar eclipse, or you've got a bushfire near you and you might need to leave very soon. So it's quite striking as well. It's the moon drops in brightness dramatically when this happens, and it goes. You can actually see the shadow slowly gobbling up the Earth, the moon, and then it just turns this orange color, and it's just amazing. And you can actually get the brightness is so reduced that you can actually take photos and have stars in the background, which, you know, if on a normal day, if for a full moon, you'd have to really have some bright stars in the middle. This is what a partial lunar eclipse looks like. So this is where the Earth, the moon doesn't fully enter the shadow, the umbra, the inner shadow of the Earth. And this is also showing you what it would look like as the moon is being eaten by the umbra, the inner shadow of the moon, as we're leading up to a total lunar eclipse. There's also another final eclipse, which is the preumbular eclipse, and it's a little bit harder to see when you don't really notice it that much, and this is because it's coming in it's only going through the outer shadow, the preumbular of Earth, and you can just see just about here that there is a shadow. There is a dimness to the moon apart from this one here, which is before the eclipse, and so we can see this here. So we have the moon entering the preumbular. When it starts entering the umbra here, this is when you start to see the actual shadow occurring on the moon and it looking like the Apple logo. And then once it's completely in, it's actually going to be orange. And depending on where it is in its orbit, if it's at perigee, which is at its closest point to Earth, or apogee, which is at its furthest away from Earth, when it's in this part of the shadow, determines how long the eclipse will occur. And this is also for solar eclipses as well. So I think it was the January 2018 eclipse was the longest eclipse for total lunar eclipse for this century. So there's not too much difference, but it's always interesting to see how long they actually do go for, because you can understand that the moon is actually moving faster than the stars around us. So what's some cool stuff can you show? So naked eye, so we've obviously got the moon, and this is a shot of it at full moon. It's our moon is the fifth biggest moon in the solar system. It was created by a massive collision between the Earth and a Mars-sized planetoid called Theia, back in the day when the Earth was still a toddler. And it orbits around the Earth on average around 384,000 kilometers, and you can fit it in between Perth and Sydney. So it's about a quarter of the size of the Earth. And it takes about 28 days to orbit around in its orbit and also on its axis as well. So it's tidally locked. We only see one side from the Earth. If you want to see the dark side of the moon, as we call it, you'll need to get on at least earn a bit and pay some money to Elon Musk to send you around there with the other people that he's planning to send on that first mission around the moon on his I think the space Falcon, the Dragon capsule on the Falcon Heavy. There's also the Milky Way and the Magellanic Clouds. So we can see here the lovely emu in the sky, and the large and the small Magellanic Clouds. So we're looking at the Sagittarius arm here. So this is a minor arm of the galaxy. We happen to be in the Orion arm, and we're actually seeing here the Perseus arm. So we're in one arm, and when we looked in the winter directly above here in West Australia, we're seeing through one arm to the center of the galaxy, and during summer when we have the Perseus arm in the sky high above us, we're actually looking directly into intergalactical space. We actually exist in this nice little bubble, and it could possibly be this bubble that's been left over from the supernova that might have created us, created our solar system, and that is in the Orion arm, in between the two, or the Orion spur as they call it. So yeah, it's pretty interesting. These are density waves. So think of it as, again, driving down a freeway, someone slammed on their brakes and caused a phantom traffic jam, and so you've got people slowing down and then driving off at normal speed. So it's pretty interesting to see all these different ways you've got galaxies, because you've got elliptical galaxies, and you've got irregular galaxies, and you've got spiral galaxies, and even then you've got subcategories in that. We also have the Magellanic Clouds are named after the Portuguese explorer Ferdinand Magellan, who first circumnavigated the Earth, and they are both irregular dwarf galaxies. So they're actually orbiting around our galaxy, and they will be consumed. And Troy says our hemisphere has the best view, I reckon. We definitely do. We might not have a pole star like the northern hemisphere do. We might have to do extra work to find out where south is, but we do have all the best stuff in the night sky. This large Magellanic Cloud is actually 14,000 light years across, and is 160,000 light years away from us. And it has about 30 billion stars. The small Magellanic Cloud is 7,000 light years across, and it's about 200,000 light years away from us, and has about 3 billion. Our galaxy has anywhere between 100 to a couple of hundred billion stars as well. You'll note there is actually a magnetic bridge between these two. The small did actually go through the large at one point, and they're actually sharing dust and gas and stars as well. Now we have also, if you go out to the where you've got absolutely no light pollution, during autumn and spring you can actually see what's called zodiacal light, and it looks like this cone of light beaming out right here, and it's faint and diffuse, and it's triangular, whitish glow. You'll see in the west in the summer, and in the morning in autumn you'll see it, and it's what it actually is in the zodiac, so of the line of where the sun goes through. And what it is it's interplanetary dust that's been reflecting the light. So we're seeing light, so we're seeing dust particles that are in the plane of the ecliptic of where the planets orbit, and that's causing the dust is reflecting that light, and also causing what we call a false dawn as well, which we see before sunrise and sunset as well. So you can kind of see there's this orange bit of light here. So it is amazing to see, and you've got fantastic skies as well. We also can see Hubble, and Hubble's now just celebrated its 30th birthday, and you can see it orbiting for us in the north, and I'll show you a website later on where you can actually get a free account and actually find out when the Hubble Space Telescope will fly over. It's a little bit dimmer. It's not as bright as the International Space Station, which we're about to show now, but it is still pretty awesome to have a look. The International Space Station, if you haven't seen it, it's pretty amazing. What got me into astronomy was my dad taking me outside when we were living in Northern, and being able to look up and watch the Space Shuttle Columbia fly over. It'd been a big deal. They, Susanna Carr and Ricard had a big story about it. It was flying over, and getting to watch that fly over when I was 9 was, I was just completely astounded. And I already kind of had a little inkling of I liked astronomy, but it really kicked it off. And it orbits at about 408 kilometers on average. So that's how high it orbits from the Earth. And it orbits just under 8 kilometers per hour. So imagine going from the Perth Hills, which is about 45 minutes on a good day, to the CBD, and you could easily do that in a couple of seconds. That's how fast it would go. It's a joint mission between 5 space agencies. There's NASA, which obviously the Americans, Roscosmos, which is the Russians, JAXA, which is the Japanese space agency, ESA, the European Space Agency, and also the Canadian Space Agency. They provide the Canadarm, which was made famous by the Space Shuttle, and it's actually on their currency as well, which is pretty amazing. It's funny when you look at the Space Shuttle. There's no real advertising of the countries apart. They just have the NASA symbol. But on the Canadarm, it clearly has the Canadian flag, so they're really impressed, and it is an amazing thing. And the Canadarm too, which they have on the space station, is incredible. It can move around, and it can actually even dock spacecraft as well. And this is a long exposure that I took of the International Space Station. Here, so you can actually see it starts off dim, and then as it's flying over, it gets incredibly bright, and it can get really bright. It's to the point that it's brighter than Venus. It can get to, I've seen it magnitude minus 3.8, and that's incredibly bright. The only thing that brighter that you'll be able to see in the night sky would be an iridium flare, which they're all finished nowadays. That generation of iridium satellites that did this little flare trick where you would suddenly see it would brighten up at the right time because the dish was very reflective, and you'd hit that right point where the light would from the sun would hit the dish at the right angle and send that light down. You'd see this big flash. And they could get to minus 8.9, and that was getting to the point where you had to turn away. You couldn't look at it directly. But yeah, it's they're viewable usually an hour and a half before sunrise and an hour and a half after sunset. They do. There are times where they aren't in the sky in the night sky. So sometimes they'll be in the morning, sometimes they'll be in the morning and afternoon, sometimes they're just in the afternoon, and then there'll be a large period where we won't see them for a couple of weeks, just because they could be orbiting when it's around over us when we're during daytime as well. So that is something to take into account. So we've also got constellations, and the constellations are areas of what we call the celestial field that have been defined by the International Astronomical Union in the early 20th century, and so they form different patterns, and there's about 88 modern constellations in the northern and southern hemisphere, and a lot of the Greek stories are actually in the northern hemisphere. You get to in the southern hemisphere, we have some quite unusual ones like Dordanus, which is the fish. There's Tucana, which is the toucan. but it is pretty interesting to see. So some of them that are quite prominent, and you can see, even in the Perth Hills, or if you get away from a lot of the from the light pollution, you can make out. Troy also says here that if you have a CV radio, you can talk to the International Space Station. Yeah, you can actually, if you've got a lot of these organisations can actually set up times with NASA. It takes ages to go through all the planning and scheduling, but you can actually have a chat with the International Space Station. I've got a friend who I went on a cruise with and he knows some connections, so we'll have to try and do it one time for Astrofest in March. With Pegasus, Pegasus was the winged horse that sprung from the neck of Medusa when Perseus beheaded her. Medusa was the Greek, I think Titan she was, who had snakes for a head, and if you looked at her, I think you turned into concrete or so. But Perseus was able to behead her, and out came forth Pegasus. And what's really interesting is you can actually you can find it in the north, and you can actually see it by having a look for the rectangle here, or the great square of Pegasus. And you usually see it in springtime for us here, in September through to November in the evening. Right about here is where the very first planet was around another star was found, called 51 Pegasus by Michel Mayor and Didier. I can't remember his surname. Sorry, Didier. But they actually had to wait 6 months to announce the discovery, because the star had gone below the horizon, and Michel's son figured it out and told them he knew where the star was, and they jokingly threatened his life if he told anyone. And when the star came back into view in the morning, they were able to confirm that yes, there was a planet around this star, and they used the wobble method. So not only does the planet get hauled by the star, but the planet actually tugs on the star as well. So they were able to see that movement of the star back and forth and were able to work out that it was a planet that's twice the size of Jupiter, and it was orbiting around 4 days, which was just completely unheard of. And that was the very first planet that we found in the hot Jupiter category of planets. And so it's best viewed during winter and spring, and yeah, just look out for the asterism, the Great Square of Pegasus. So another one we've got is, we'll go through some of the zodiac signs. We've got Taurus. Now Taurus is associated with Zeus, who adopted the shape in order to seduce and abduct Europa, the beautiful daughter of the Phoenician prince King Agnor. And if a really good audio book or book if you want, Stephen Fry has created a book back in 2016 called Mythos. I'm still going through it. It's fantastic. It's definitely a good yarn, and he actually does the audio book, which is even better. It's best viewed during summer and fall. It's one of the 12 constellations of the Zodiac, and it's known for the bright star called Aldebaran. So this is the red eye of Taurus. It's a star that's coming towards the end of its life. It's a red giant. It also has the Pleiades cluster, which is easily seen, and that's if you drive a Subaru. The Japanese call the Pleiades cluster this Subaru. And it also has another asterism. So asterisms are not officially constellations, but they're patterns, easily recognizable patterns in the sky. And this is the Hyades. So you can clearly see that there's this Christmas tree effect, a line of stars, and that's called the Hyades, and that's the head of the bull, and then we go down with the horns. Next up, after Taurus, is the Orion constellation, and Orion was a hunter, and he was the most handsome man in the world apparently. Fabio, he's considering the new Fabio. It's again best seen in summer and fall, and Orion fell in love with the Pleiades, or the Seven Sisters, and they were the daughters of Atlas and Pleione. And so Atlas was the Titan that Kronos beat, that Zeus beat, and he made him, because he was a rival, he made him hold up the sky, and also by doing that replaced Uranus, and who was the father of Kronos, who was the father of Zeus, and Kronos had beaten Uranus, so there hadn't been a sky god for a long time. So he took out a rival and also found a sky god in the middle. So we name Atlas our atlases of the maps of the sky and of the Earth after Atlas, and he's represented by the guy holding up the world. And so the Pleiades are represented by they're always one of the oldest stories, because they're all, when you listen to all the different ancient civilizations, they're always got 7 daughters or 7 wives or 7 women. So it would be interesting to go back in history and actually see how the story, where the story began, and whether it was one of the very first stories. It's also Orion's also known for a couple of things. We've got the Orion Nebula, which is right above here. So this is his sword, where he puts his sword when he's not hacking away, or his club. We've got Orion's belt, Betelgeuse, the star that's almost ready to die as well. We thought nearly had a heart attack at the beginning of the year, which was seen so far long ago. And also Rigel is a supergiant, not a stupid star, but a supergiant star. So if you put that in our solar system, it would gobble up all the planets, even to Jupiter. So it's pretty amazing. Now, Juice Dog says, what happens to stars when they die? Well, in terms of our sun, what will happen is it'll end its life as a red giant. So just like Betelgeuse or Aldebaran. So they run out of hydrogen, because the stars work on converting hydrogen into helium. And so the core heats up, and it can then, so you have a small layer of hydrogen around a core of helium, and then the core heats up so that it can convert helium into other elements like oxygen and nitrogen and carbon. And so as this is happening, the star is getting bigger and bigger and bigger, and as this is happening, it's turning color to its color from, say, either it could be blue, or it could be white, it could be yellow, it could be orange, but it will turn red, because even though the core is really hot, it will actually it can't heat up that huge star as it's expanding, and it also starts leaching off the outer layers as well. So you'll end up getting what's called a planetary nebula, where you get these shells of dust and gas coming off the star, and towards the end of its life, where the core will actually, when it starts to try and fuse iron, that's the point where the star loses its battle, because it's a constant battle between trying to explode and also the gravity of that star keeping that explosion in place. So once it starts fusing iron, that's when it loses its battle with gravity. The core will collapse, and it will our star will end its life as what's called a white dwarf. But you can, for stars that are 8 times the mass of our sun, they can end up as supernovas where they blow up and you can get a neutron star, or if you get a star that's more than 15 times the mass, and when we say mass we mean how heavy the star is, not how wide it actually is. Once it's about 15 times the mass of our sun, that's when you can get black holes from the supernova. How many Goldilocks planets are there known? I think they're in the hundreds. The problem is, if they're not in the tens, they're in the hundreds. A lot of them will be orbiting around stars called red dwarfs, which are the smallest stars. The problem with them is, even though they last a very long time, which is great because life takes a long time to come together, it does actually, these stars can have a lot of flares which can strip away planets' atmospheres. And they can also, the Goldilocks zone is so close in that they're tightly locked. So one side will look like probably a desert, and the other side, the night side, would look like a frozen wasteland. So we'll go on to the next one. Now, Orion has 2 dogs. The Canis Majoris is the greater dog, and again, it's best viewed in the summer and fall. Canis Majoris can easily be found because it's got the brightest star in both hemispheres, Sirius. So I always like to joke about how the Joker says, "Why so serious?" It's got a couple of cool things like the tall Canis Majoris star cluster, or the Mexican jumping star cluster, and also what's called Winter Albireo, or Herschel's lovely double, which are 2 stars that look like they're binaries, like they're orbiting around each other, but are just ships passing in the night. But they do actually have, one's blue and one's yellow. It's pretty cool to see in the night sky. We also have Gemini, and they can be found if you in summer and fall as well. It's quite easy to pick them out because there's Pollux and Castor, and usually the Geminids, which are the meteor shower that's named after them in mid-December, they actually usually appear around here. That's the radial point. So if you were to draw all the lines through all the meteors that you'd see overnight, all those lines would eventually end up around here. And again, it's one of the 12 constellations of the Zodiac. There's actually 13 constellations. There's Ophiuchus, who's the serpent handler, is also in the zodiacal line. It's just apparently we don't have room for him in our zodiacal signs. They're also known as the sons of Zeus as well. So the story goes that Zeus had kids with I think it was Europa, and these are the 2. So there's Castor and Polyjuice, and that's what we end up now calling Pollux. And so Pollux was immortal, and Castor, because it's dimmer, is the mortal twin. And they're great generals. They do mighty battle, and they end up Castor ends up biting the dust a little bit too early, and Pollux is besotted and pleads with Zeus to please make him mortal so that he can join his brother in the sky. And he ends up living out his life and joining his brother in the sky, which is pretty unusual for Zeus, because there's always usually a catch-22 with Zeus with if you want stuff from him. We also have Leo. So we've got the people who are Leos. I think my dad was a Leo as well. Again, a summer and fall constellation. Leo's associated with the Nemean lion, the beast that was killed by Hercules and is the first of his 12 labours to make him a god. Again, it's another constellation, zodiacal constellation, and it's recognisable by Regulus, which is actually a multiple star system. There's also, in this area around here where his tail is, there's the Leo triplet galaxy, which we showed in one of the live streams that we do on Saturday. Also, Wolf 359 which is one of the nearest suns, and only Alpha Centauri star system is closer to us, which is in and also the Barnard star in Ophiuchus are closer. You might know this also from Star Trek, because that's the Battle of Wolf 359 is where the Borg assimilate Captain Picard and obliterate the Starfleet ships, and also only leaving a few survivors, which is among them is Benjamin Sisko, who becomes the captain of Deep Space Nine. So I can talk a little bit more about sci-fi now that Roger's gone, and I'm on my own. But so it's interesting to see how all these different sci-fi shows bring in different stars, nebulas, constellations as well. And Star Trek does a good job of introducing correct terminology and right star clusters and all that kind of stuff. We also have the Virgo cluster, and this is where the supercluster is. So there's a great number of galaxies in this location here. It's known for Spica or Spike. I usually say Spica, but it's it's a summer fall, but you're now getting into the fall autumn part of the season. Spike is a double star as well, so it's nice to see. You do need to have relatively dark skies to be able to see the full constellation, but getting to see the galaxies are pretty awesome. Now, one of the other clusters that you can easily see in the night sky is Scorpio, and Scorpio was identified as the scorpion that killed Orion. Orion killed one of every single animal, and the god said, "Good job, we want to put you in the night sky." And he said, "Just give me a sec, I want to kill every single animal." And Gaia's like, "No, you're not. If you do, I'm sending a scorpion." And Orion basically goes, "Watch me." And he starts hacking away. And so Gaia releases the scorpion, and they do mighty battle. And Orion bites the dust, and so that's why they're on the opposite side. So when Orion sets, Scorpio rises, and then when Scorpio sets, Orion rises, and that's him coming back to life. When Orion sets, that's him dying because of the scorpion. And Antares, which is another red star, which is another red giant, another star about to bite the dust, that's called the red heart of the scorpion. But there's some really nice star clusters in the Stinger here, so you can see here the arms and with the pincers on it, the head, the body, the tail, and here's the Stinger. Around here is the Butterfly cluster and Ptolemy's cluster, which are really good to have a look at. We have Sagittarius as well, which you can see as the asterism, the teapot. So you can see up his head. So he's the centaur. There's half man, half horse, and he's depicted with the aiming an arrow towards the heart of Scorpio. Again, another zodiacal constellation, and this is where the central black hole is. This constellation here is why we call our black hole, the supermassive black hole at the center of our galaxy, Sagittarius A. We also have another centaur, the Centaurus constellation, and this centaur is Chiron, who is the wise centaur who mentored many well-known Greek heroes like Achilles, Jason, and Hercules. Unfortunately, he didn't warn Achilles about his Achilles tendon. Why we know why we've got our Achilles, why it's called Achilles tendon. In the Battle of Troy, he dies because he gets shot, I think, through by an arrow through his Achilles tendon, and that makes him beatable. We've also got some cool stuff here. In there, you've got the Southern Cross, which is its own constellation, which we'll talk a little bit later. We have the pointers, so our Alpha Centauri, which has which is a triple star system. You've got Alpha Centauri A and B orbiting around each other, and then Proxima, which is the closest star to us, orbiting around there. You've also got Omega Centauri, which is around here, which is one of the biggest globular cluster, really bunch of old stars, about 10 million of them in a big ball. And there's also around this area here as well, the Centaurus A galaxy, which we've, again, both these objects we've shown on some of the on the live streams through the telescopes. If you want, you can go through our YouTube channel and have a look at those. And we have the Southern Cross, which is our final constellation to go through. It's actually called the Crux. Best viewable through fall and winter. It's circumpolar, so it doesn't leave our night sky. But here at the Perth Observatory, now south of the viewing area, we've got a whole heap of trees, so we do lose it for a bit of the night sky tours. But Ptolemy actually listed the stars as the Crux as part of the Centaurus constellation. By the year 400 AD, the constellation was not well visible to most Europeans anymore, and it was only until they had the great naval expeditions like Magellan and that, when the Europeans came down to the southern hemisphere in the late 15th and early 16th century, that they that the Europeans rediscovered it. There's also a really nice, next to B, so we've got Alpha Crucis, Beta Crucis, Gamma Crucis, Delta Crucis, and Little Epsilon. Wrong one here. So we've got Alpha Crucis, which is double star, Beta Crucis, Gamma Crucis, Little Epsilon Crucis, Delta Crucis, and Little Epsilon Crucis right here. And right next to Beta Crucis is the Jewel Box cluster, which is really nice to have a look at. Got some nice colours. There's the three central stars have different colours, which we call the traffic light, unofficially call the traffic lights. So we do have some cool stuff that we can see through, not just through naked eye, but also through binoculars. You can see Venus through binoculars. Venus is our twisted sister. It's literally hell on it's hell for our solar system. It orbits the sun every 225 days. A day on Venus takes 225 days, but it actually takes 117 days to orbit around. I'm getting it fixed up. It does take 225 days to orbit around the sun, but it takes 117 days for a day on Venus. So it's actually 2 days on Venus is longer than its orbit. Now, the reason we call it hell in the solar system, and also Earth's twisted sister, is because instead of being this nice planet, which we always thought about, its surface temperature is 462 degrees Celsius, which is enough to melt lead. Its atmosphere is made up of carbon dioxide and thick clouds of sulfuric acid, and that atmosphere is 80 times more dense than the Earth. So if you were to land on there, not only would you melt, but you would be crushed at the same time. And because it's an inner planet, it has phases of the moon as well. So even Mercury, which is another binocular object, will have phases. It's just a little bit harder to see because it's very close to the sun. But you can clearly see here that Venus is in a crescent phase right here. And you can still see it at the moment. It's very low. It's low in the evening sky at the moment. Jupiter, even though this image here was taken through a telescope, you can still see Jupiter. It'll look like a big bright dot, but you can even see its moons through the binoculars as well. So it's great to see. Even when you can see the bands and even the red spot through a telescope as well. We've got the Pleiades cluster, which you can see. So the Seven Sisters, which we talked about. There's about 3,000 stars to this cluster. They're only about 100 million years old. So think of them as toddlers, and they're very close to us at about 400 40 light years away, and they're actually elongated. It was we've got the European Space Agency has a telescope called Gaia, and it's constantly taking images of the night sky, so we can actually see the stars and plan out where they're going to be moving. And what we've actually worked out is that the brightest stars are actually closest to us, and it's elongated as well. It's not perfectly circular, it's actually elongated, and it's been quite hard to figure this out because of the dust, but it's only been recently with the Gaia missions that we're able to easily work out how far this cluster is away from us. We knew it was somewhere between 400 and 500 light years away, but we've been able to accurately measure it now as 440 light years away from us. We have the beautiful Orion, which you can see through not only binoculars but also telescopes. It's a massive cloud of dust and gas. So think of this as a star nursery. This is where baby stars are formed. Best seen during with the Pleiades, best seen in summer and fall. It's about 25 light years across, and it's the closest star forming region to us. There's many of these stars that we've seen through with Hubble have actually got planetary disks around them. So there's planets being formed, or maybe even sibling stars as well. And in the center, there's a bright 4 stars which you can see through the telescope. And they're in the center, and they're called the Trapezium cluster. They're really massive stars, and the radiation coming off them is blowing away a lot of the dust and gas in the center. Now, we can also see Andromeda. It's very low on the northern horizon for us here in Perth. It is the closest galaxy to us. It's also the largest galaxy in the local group of galaxies. We're the second biggest. It's just over 2.5 million light years away from us. Best seen in spring, so we usually get to see it 2 weeks of the year during our night sky tour, where it leaves the trees and then traverses across the sky and then gets blocked out by our big Perth Lowell telescope dome, and then it enters the light pollution of Kalamunda. So for 2 weeks of the year, we can usually get the telescopes down. It's so big that if you look through the eyepiece of the telescope, you'll only just see the core of the galaxy, and you use the finder-scope or binoculars to see the whole galaxy as well. So give it another 4.5 billion years, and there will be a merger of the Milky Way and the Andromeda galaxy, and it's also the most distant object you can see with the naked eye as well. So we go on to telescope targets. Well, great thing is that Mars is coming around, and we're coming around to the part of our orbit where we're very close to Mars. You'll notice in the next couple of months that you'll see a spate of launches to Mars. So I think the Mars 2020 rover, which I believe is called Perseverance, that's getting launched in July, I think it is. And there's might be one from the UAE as well being launched. So even more satellites and landers and probes being sent to Mars this year. It's the 4th planet from the solar system and the last of the terrestrial planets. It's about half the size of Earth, and it takes 687 days to orbit around the Sun. A day on Mars is very similar to Earth. It's just about 40 minutes longer. So keep have the Mars scientists in your thoughts, because they basically every day they have to get up about 40 minutes later each day to go to work. And so especially the people who were on the Opportunity mission, landed rover mission, which was only supposed to last 90 days and it lasted nearly 15 years. That might have, they probably weren't expecting to be doing this routine over 15 years. So it's called the red planet because the top layer of soil is this brownish red, and it's because the top layer is basically rusting. It has the biggest, Mars does, even though it's only about half the size of Earth, it has to try and outshine Earth. Everything's bigger on Mars. The largest volcano in the solar system is on Mars. It's 21 kilometers high, 600 kilometers wide. So imagine it's being basically the size of France, and you could easily walk up it without putting too much effort into it. It's just a fairly easy gradient because it's so long. And the reason you can get such large volcanoes is because there's no tectonic plates moving on Mars, and so when you have these hot spots like we do with what ends up under Hawaii, where because the Pacific plate's moving, this hot spot is the tectonic plate is moving over this hot spot, so you get island as the continent happens. Well, that doesn't happen. The hot spot makes a hole, and it just keeps on erupting until it settles down, and you get this massive big volcano. It has the largest valley, Valley Marineris, which is 4,000 kilometers long, which I think is longer than the US and also Australia, 200 kilometers wide and 7 kilometers deep. So, the Grand Canyon would just be a small little offshoot from Valles Marineris. So, and it experiences huge dust storms as well. Now, if you've watched The Martian, they can get winds of up to 150 kilometers per hour or whatever it is, but the thing is, because there's only 1% of Earth's atmosphere, the pressure of that wind or dust is only like a harsh breeze. So it is, Andy Weir did take some poetic license with the book, but it is still a fantastic book and movie as well. We have Saturn, which is, you'll always get someone go, wow, when they have a look at Saturn. And the yellow appearance comes from ammonia crystals in the upper atmosphere. You also have, you can also see some of the moons. You can definitely see Titan, which is the only moon to have an atmosphere, and it's actually bigger than Mercury. Sometimes you'll be able to see Rhine and Tethys and that. On a really good night, you'll be able to see Enceladus, which is a moon the size of the UK, and it has geysers of shooting water from an ocean underneath the moon's ice crust. And the rings, if you fit them around, they would extend from almost halfway to the moon around the Earth, if you were to put them there. They're very, very thin. They're only about 20 meters in thickness, and they're made up of very fine pieces of rock and ice as well. The other objects that we can show you is the Tarantula Nebula. It's the furthest object that we can show you that's not a galaxy. Again, another star nursery. It's a nebula, 700 light years across. There's about 800,000 stars and protostars being formed at the moment. It's the most active star forming region in the local group of galaxies that we can see as well. If you were to bring that to the same distance as Orion Nebula, which is about 1,344 light years away from us, it would take up about 60 full moons worth of sky in our night sky, and you could actually read a newspaper from the light. It's 160,000 light years away from us. We have the 47 Tucana, a really cool globular cluster to have a look at. 10 million stars. It's 120 light years across. It's about 13.1 billion years old. We have the Jewel Box, which is right next to the Southern Cross. Lovely open cluster. So these are baby stars. This is what happens after a nebula has used up all the dust and gas it can to make stars. There's about 100 in these cluster. It's about nearly 6,500 light years away from us, and it's about 20 light years across. There's Albireo, which is located in Cygnus, so it'll be in the north during winter and spring. They're two stars that are orbiting around each other, about 415 light years away from us. and they think the orbital period of those two stars, because they're orbiting around a central point, is 100,000 years. That's how long they take to orbit. Other galaxies to have a look at is Centaurus A galaxy. Best seen in it's in Centaurus. Best seen in fall and winter. It's 16 to 10 to 16 million light years away from us. It's fairly close to the same size as us. It's 97,000 light years away across. And we're seeing the galaxy edge on as well. And you can see that there's a disturbance here in the dust clouds, and that's because there's been a collision. And there's a starburst affecting that, because dust and gas is making stars, and also there's dust and gas falling onto the black hole in the center, and that's causing the stars to, the supermassive black hole to feed, and causing X-ray and radio jets to come off the north and south poles, which you can easily see. Well, you can't see it, but we can see with the Chandra X-ray telescope. We've also got astronomical events for the rest of the year. We have solstices and equinox. So we're coming up to the winter solstice, the shortest day of the year for us in the southern hemisphere, on the 21st of June. We have the spring equinox, when both sides get equal light, equal share of the day and night, on the 22nd of September. The summer solstice, where we get the longest day here in the southern hemisphere, is the 21st of December. And again, our autumn equinox, where we again have equal parts of the day and night for both hemispheres, is on the 20th of March. And you can see a little representation, because the Earth is on a 23% incline, or 23.5% incline. As we don't always get the same amount of light as we go through the year. We also have some preumbrral eclipses. So preumbrral lunar eclipses. So we're coming up to one on the 6th of June. If you want to get up, it's probably best to go see it at 3:30 in the morning. There really won't be much difference. But you can always, if you want to take some shots of it, say a time lapse, you can, and it's going to last a few hours anyway. We also, so you can see the path here, so it will be visible for most of Africa, the Middle East, Central Asia, and also, Mel, I'll put it also the diagrams. I'll put a link to this this presentation in the chat after, and also most of Australia as well. We have a very, very short preumbrral lunar eclipse for us. Only 49 minutes here. It's on the 30th of November. We've had 3 preumbrral lunar eclipses in this year. I think we get another total lunar eclipse next year. I think so. I think this is the year where we don't really have anything special in terms of eclipses, but apart from preumbrral lunar eclipses. So that's another one. This is a little bit more easier time. We'll start to see it at 7:07 in the evening. 3 minutes after, it will be max, and then we'll. So you won't see that whole effect. Well, you won't. It will be just too low on the horizon for us for when it begins. So it'll be. Again, it's worth going out and having a look. Again, here we can see the pattern here. So this is why it's only a short period. We're not seeing the whole event. We're seeing just the very beginning of it. We have supermoons and micromoons. So they're really so a supermoon and a micromoon is a supermoon is a full moon or a new moon at its closest point to Earth, and a micromoon is the technical term for when it's at its furthest point and it's a full moon or a new moon. And so we've got micro moons, so there'll be very small moons on the 2nd of October and the 31st of October. And then we'll have super full moons in next year on the 26th of April and the 26th of March as well. So you can kind of see the difference here. There's not much real difference between a normal size moon, a full moon, and a super moon. But when you compare the micro moon and super moon, there is about a 14% big. The super moon's 14% bigger, and it's also 30% more brighter as well. So in terms of meteor showers that are coming up, we have in halfway between July and August, we have the Delta Aquariids. So their peak night is the night of the 27th, 28th. It's reasonable time as well, 10 p.m. to 6 p.m. So you might want to go out there about, say, midnight to 2 a.m. Caused by the Marsden-Crux sun-grazing comets. So this was a bigger comet that got too close to the sun, broke up, and you've got these trails of these bits and pieces of comet that are orbiting around. You should see about 10 meteors per hour. There is no light, so there's no light pollution for this year, because the moon won't be up, so moon won't be an issue. And you just have to look at Aquarius. You don't have to look directly at his crutch, but if you look in that general vicinity, you might be able to see a few meteors. You do have to get out of the city. It's like even here we only see fairly bright ones to medium brightness, but if you're in the country, you get to see the full 10 per hour. We also have the Orionids, which is caused by Comet Halley, and they'll peak on the 21st and the night of the 21st, 22nd of October. Not a great time for people that work during the day. It is 1 a.m. to 4 a.m. You should see about 15 meteors per hour if you're in the country. I'd say about 5 to 10 if you're in where we are in the hills, or maybe even 1 to 5 if you're in the city. Again, there's no moon during this time, so during the best time, so the moon won't be an issue. And what you need to look is go out at about, say, 2 a.m. Look northeast, and you'll see Orion here. And just look towards Orion. You'll be able to see. You should be able to see some nice streaking ones. We also have the Leonids. Now, Leonids is always fascinating because every 33 years they have an absolute storm, but we're in the middle of in between two. So the last one was 1999, and unfortunately it was cloudy both here in Perth and in Sydney where I was living at the time. But there's stories from Dave Dickinson, who's a well-known science communicator and astronomer, and he was working with the US military, or for the US military at the time, Air Force personnel, and he was in Kuwait, in Qatar, and they went out to the desert, and apparently it was like watching rain, like a shower. That was a rain shower. That was how much stuff was hitting our atmosphere. But again, so the peak night for this is in the 18th and 19th of November. Again, terrible hours, 2 a.m. to 4:30. This is caused by Tempel-Tuttle, the comet, and there's no moon, so you should see a few in the suburbs as well. So you'll need to look towards Leo. So look for Regulus and also Pollux and Castor. You can always use an app for that, and look towards the head of Leo, the lion. And finally, we've got the Geminids. So there's no moon during this one, so this is going to be fantastic after last year having a full moon, which is a pain in the rear end. Again, the peak is between the night of the 14th, 15th, from 11 p.m. to 4 a.m. We'll have a night up here at the observatory, which you'll be able to book on. Just look for closer in the day, closer to the date. If this is actually caused by a asteroid that doesn't know whether it's an asteroid or a comet. It actually shares some. It has some rocky jets on it, even though it is actually an asteroid, and it's called 32,000 phaeton, 3200 phaeton. And you can, here in West Australia, you should be able to see about 60 in the bush. We usually get about 10 to 20 here in Perth Observatory with the light pollution, but it's definitely one if you want to go camping out in the central wheat belt. Book some time around that time, take holidays a little bit early and go out and see it. So where to look? Make sure you find Orion, find Aldebaran, and then you can just draw a line between them, and you can also find Pollux and Castor, and that's where it is. Conjunctions. We got two really nice ones. There's we just had one recently on the 22nd of May, which was Mercury and Venus low on the horizon. They should still be fairly close. You'll also have this December 22nd, Jupiter and Saturn very close. I reckon you'll be able to see that through a telescope as well. So let me just double check what date that is, because that might... Let's have a look. It's a Tuesday as well. So definitely if you've got a telescope or even binoculars, make sure you go and have a look at that. It's early evening, so about 8 a.m. to 8:30, go out and have a look, and they'll be quite noticeable as well. So we've got some Indigenous astronomy here. So we have the Milky Way, and so this is the Sagittarius arm, and the Indigenous people were actually they didn't have so much as the point-to-point of stars for their constellations. There are some constellations which they had named after for their constellations, but they looked for dark patterns in the sky, and so the big one that they know of is the Sagittarius arm in winter, and we have the Emu in the sky, and so you can see there's the Coalsack Nebula, which is the head of the Emu. We've got the neck, and then the body, and then the legs go out there, out towards the constellation Scotum. So the Yungan people actually see it as a mighty river. So they don't always see it as an emu. The desert people see it as a rainbow serpent, and the Barung see the southern constellation as a Southern Cross as a tree as well. So it's interesting to see all these different stories. And on top of that tree, the Barung people see a possum on top, which is pretty cool. The Magellanic Clouds are circumpolar as well, so they're always in the sky. The people of Arnhem Lands tell us that the clouds represent a camp of old people, an old couple who can no longer obtain their own food. The Barung people see them as a pair of Borlagas, which are Australian cranes, and while others see them as two brothers who come to collect the dead spirits of dead people as well. Auroras as well. So this is something that happens all over for the whole of the Earth's history while we've had a magnetic field and atmosphere. And the Indigenous people would see the auroras as fires in the cosmos. The Naram traditions of the East and Victoria see them as bushfires in the spirit world, and an omen of coming catastrophe as well. Diri and the Ngarrindjeri people of South Australia see the aurora as fires created by sky spirits as well. The sun and the moon also have really good stories, and the Indigenous people of Australia would normally see the sun as female and the moon as male. I'm really sorry for these pronunciations. The Yurungun people believed that the sun was Walyu, the sun woman who would whose light the fire who would light the fire each morning, and she would travel across the sky and then return back. And when she would the sun would set, that was her finishing the day and coming back to her camp as well. She lights the fire with stringing bark, and that bark is what she is the torch that she carries as she traverses the day. At sunset, that torch extinguishes, and the Yulungun peoples believe the moon is the moon man, who is fat and a lazy man. He demands his wives and son feed him, and eventually the sons refuse and he kills them. The wives find out and attack him with axes and chop him up into bits and pieces. So this is him going from a full moon phase where he's big and fat to, as it becoming last quarter, he's being chopped up. And then he tries to escape by following the sun, but dies, and he remains dead for 3 days, which is the new moon phase. And then he comes back to life and begins feeding again and gets fatter, and that's the first quarter phase. And then the wives attack him all over again once he reaches full moon. So yeah, it's really interesting to hear all these different stories of not just the Greeks, but there's the Babylonians. The Japanese had stories as well, and it's good to see planetarium software like Stellarium being able to put all these different civilization stories of the night sky as well. Astrophotography, if you're into that, some tips for it. So this is a shot that I took from New Norcia when this was on a workshop that Roger Groom did with Carol Redford from Stargazers Club. We got a really good chance because you had the moon right in the middle of the Milky Way, and so we got some nice shots of the monastery there, and they do have fantastic bread as well at New Norcia. So definitely get a sturdy tripod, and also use a ball mount if you're going to use wide field for nightscape shots. Use the camera delay or use an intervalometer. That way you don't the camera's not moving as you press the button to take a shot. If you don't have an intervalometer, which you can set delays and set how long the exposure time is for. Using the camera delay where it takes a couple of seconds to take shots before it starts taking shots, so it lets the camera settle. Also use manual mode as well, and use a manual focus. Don't use the autofocus, and also use the live view. When you're setting up for the very first time, Roger was really good at showing me how to focus, and what he told me to do was get a bright star. Say 2/3 of the way between the center and the far edge, and use that bright star and with live view of your camera to get it nice, get it properly focused. Use a fast aperture, so you want to set your camera anywhere between say f to 2.8 to 2.4. Set your white balance to daylight as well. When there's no moon, you can do your exposures between 15 to 30 seconds if there's no moon and no light pollution. You will start to get some star trails if you get towards 30 seconds. So 20 seconds is you won't get any real star trailings. But you can do longer exposures if you have a tracking mount, which you can get from Camera House, Midland, or Camera Electric as well. So And also, if you are in the city, or you've got light pollution, or if there is a moon, 5 to 15 seconds, you'll get a nice image, and you won't get too much overexposure. It's good taking the same shot at different exposure rates as well, and you can use the 500 rule as well. So, you divide 500 by the focal length of your lens, and that should equal your longest exposure. So that image here. Sorry, go back. Oh, it's that image there. I think I had it as it was 500, and I was using my lens was a 20mm lens, which meant I could go 25 seconds before you should really start getting long exposures. And yeah, it was come on, go back. And also use, depending on how, it's good to get the camera out and let it cool down. In summertime, you can use exposure times of say 400 to 2400, but usually you want to set it to about 1600, just because it's so warm. During winter time, where it's a little bit cooler, you can go up a bit. So you can go 1600 to 3200. So if you're really nice cold night, you can go up to that 6400, or even 128,000 if you've got that on your camera as well. So these are your ISO settings, let your camera adjust to the coolness as well. And also shoot RAW and JPEG. So if you've got a Nikon camera, I think it's NEF file. So that's the really super high res. I use Adobe Photoshop and Lightroom to edit my photos. And you can also use, there's also light pollution filters out there to reduce the glow from artificial light as well. So you can even get mobile phone adapters from stores. This is what I have in my kit, so that I can use my phone to take images of, say, the moon. It's good if you're able to do it if it's just by yourself, and if it's one of those cases where we have a night sky tour, it's just easier for us to grab your phone, put it on the eyepiece, take the photo of the moon and hand it back, and then go to the next one. But if it's just yourself and you've got your telescope, highly recommend it. It's called the ScopePix Pro phone adapter. This one fits on both 2-inch eyepieces and 1.25. Bino Central here in Joondalup sell it for just under $50. That was what I got it for back 2 years ago, I think. But you can actually do some decent astronomy now, and this is an image that one of our volunteers took, Jeff, with his camera. And from some of the latest Galaxy phones and Apple phones, these cameras are seriously getting really good. Apps and resources to use. If you're looking for a telescope, really good starter is a Dobsonian telescope, designed by John Dobbs for street side astronomy. They're really good optics, built tough. We've had people try to ride the telescopes when we've gone down to the Perth Cultural Centre, and they still work fine. They're easy to set up, but they don't have any tracking and go too remote. But it means that they can quickly be moved, and you also learn how to move a telescope. The 10-inch version will set you back, just under $1,000 or so, but well worth it. And you can get them from Camera House, Midlands, and also Bino Central in Joondalup. If you do want to get a telescope that's that has go-to features, so that you can set it, align it on a couple of stars, and then be able to use a remote control to send it to different targets. The Celestron CPC 1100 Deluxe 925 is really good. We did a live stream with the bigger version, the 1100. So they're really good all-round telescopes. It'll set you back for $5,500, and you can buy them through Bino Central here, or you can order it from Bintel in over east. But Keith's really good at Bino Central, so give him his chance. Give him his business. Binoculars, anything around that 7x50 sports binoculars are really good. They've got a good range of both for sport, astronomy, and also boating and night use as well. They have 7x magnification. With the 7x magnification, the binoculars bring in a maximum amount of light, and they retail between $120 and $115. I still have my Celestron pair, and when we go out to, say, Central Wheat Belt, I'll still use them to try and find objects that I've never seen before, and then get my telescope on there. Again, you can buy them from Bino Central. In terms of software, Stellarium is what I've been using. So you might have seen when we've had cloudy nights and I've been running the live streams on Saturdays based from my desktop here. I'll use Stellarium to show you, where it is in the sky. Really good software. There's the computer version's free. You can download it from Stellarium. Desktop Android versions there's a free version. It does have ads, but there's also Pro version and a Super Pro version, which costs and you don't get ads. And I think you can also run your telescope off it as well for the very pro mode. Because there is no free version for the iPhone, it does cost you about $4.50, but you don't get any ads with it. For Heavens Above is fantastic if you want to learn, if you want to find out when the International Space Station will fly over, or when Hubble or bright satellites will pass over. So you can get a free account, and you can put in your location, so you can see Perth Observatory in the top left or top right here. And what ends up happening is you can then go, once you've logged in, you can then go to the International Space Station, and you get a list of the times here, and you can click on the dates, and that will give you the flyover. And so what you do is you look south, hold it above your head, and then you can use the little compass points here. So we've got northeast, northwest, southwest, and southeast here to see where the orbit is. And you can also use where the bright stars are as well. And so it's really good to find the bright satellites. And there's actually an Android version, but unfortunately there isn't an iPhone version. But as an Android person, there's enough stuff that's not on the Android platform. We've got to have something for ourselves. But if you are an iPhone user, best to download ISS Detector. It's free, and you can use that as well. Timeanddate.com is really good. Dedicated to all things time and astronomy. So you can moon rises, sunrise, sunsets, moon phases, when eclipses and meteors are happening for your location as well. We do have sunrise and sunsets and moonrise and moonsets and phases of the moon on our website, but they're just purely for Western Perth and Western Australia. If you're outside of Australia, highly recommend Time and Date. They've been very good to us, and we help them out with the streaming total lunar eclipses and total partial lunar eclipses, and hopefully when we have a total solar eclipse we'll be able to partial solar eclipse we'll be able to work with them on that as well. Also, Astronomy Australia 2020 book is really good. Usually Astronomy, you'll probably see Astronomy Australia 2021 come out, say November, December, coming up to Christmas. We can sell it here. We sell it here at the Observatory for $29.95 if you're interested. It's really good. It goes into quite a lot of detail as well about each month and what's happening and what events there are. There's also, if you're really interested in learning more about the Indigenous astronomy, there's a really good book done by Dr. Ray Norris and Cecilia Norris. It's really easy to read. We've got it here at the Observatory for $15. I bought it for my niece who is getting into astronomy as well. Yeah, if you want to find out more about Aboriginal astronomy, head to aboriginalastronomy.com.au. It's really good as well. So, it's over. He's finally finished. I finally finished, guys, and thank you very much for staying in. I know it's a little bit, it's gone for a long time, but there's so much cool stuff in our night sky that hopefully you've enjoyed it. If you have, please subscribe to the page, click the notification, and also if you have any questions and you're in the Discord chat, you can always leave them here in the chat, and we'll answer them after the chat as well. So thanks guys for joining. This is going to be the last public talk. We'll still do the live streams up until we're going to reopen, so that should be decided in the next couple of days. So stay tuned to our social media and our website as well, and you'll know when we restart, so you can book a night sky tour here. Thanks very much, guys. I hope you've had a fantastic night and you really enjoyed this, and we'll see you on Saturday night for our live stream of the night sky. See ya.